Okay, probability of mutually exclusive events. You're mutually exclusive if you don't share any common elements. That's just a reminder. There's no overlap on the Venn diagram, no intersection. And so a reminder, this is obviously a mutually exclusive scenario where the elements of A and B do not overlap. There's nothing in common. There's no intersection. So basically, if we're using pi, if we remind ourselves, pi tells us this, okay? The union of the sets is taking A, taking B, subtracting anything that they have in common. That's always what pi is stating, okay? If the events are mutually exclusive, we know that the intersection is just nil, right? It's zero, okay? In this case, there's nothing there. So then we just know that don't worry about the intersection, you just add it up, okay? This is what we ended up doing when there's no intersection, so no surprises there. So this is just a refresher of what pi is stating, okay? We can do the same, we can take the same reasoning when we're doing probabilities, okay? Make sure you follow along. When dealing with probability involving inclusive events, the probability of A or U, A or B is probability of A, probability of B, minus probability of both of them. If the events are mutually exclusive, right, there's conditions or restrictions that do not affect each other, then the probability of A or B happening is just take A or B. Examples. I'll give you some examples for mutually exclusive. Okay? Rolling an even number or an odd number. There's no overlap, correct? There's no even number that is also an odd number. That's just a classic example. Another one would be drawing a red card or black card. Do you need to worry about any overlap there? Is there any red card that is also a black card? No. So dice and deck of cards, they will be used when it comes to this to test your knowledge. So these are mutually exclusive, okay, disjoint, right, or disjoint. That is another word that I want you to disjoint. Okay, so these are mutually exclusive or disjoint. Okay, so using the Venn diagram to the right, choose some answer everything here using this diagram. Maybe I will add here, I will use this section here for non-mutually exclusive. Examples. Write this down. I think it's good to have examples. A drawing a heart or a king. Would that be mutually exclusive? It wouldn't be. I have a deck of cards, but by the time I find that king, it'll take too long, right? But there are 13 hearts, and one of the hearts is a king, okay? So if you think of your hearts, there's 13, and how many kings are there in a deck? 4. But there's one that they share in common. There's one king, right, that belongs to the hearts. It's also part of the king, so that's what it would be. How would you fill in the rest here, by the way? This would be 3, and this would be 12, correct? you'd have 52 out here. And you have your outliers. So right now, how many cards are we talking about? This is 13 and another 3, that's 16, right? So you get a 52 minus 16. So there's technically 36 outliers in this case. So this is non-mutually exclusive. I will highlight that and I'll say, hey, in this case, you can't just go 13 hearts plus 4 kings and that's it. You gotta subtract the 1. You gotta make sure you do not double count. Okay. So let's fill out this Venn diagram here. Using the Venn diagram to the right answer, n of A and B. Okay. And we will do that. Actually, I made a mistake. There's a typo here. I made a note on my, this is supposed to read union, because that's how pi starts, right? The union of A or B, that would be NA plus NB minus, we always write this down just in case. If there's an overlap, then we subtract it. If there isn't one, then this is just 0. Okay. Let's fill in our Venn diagram here real quick. In this case, we would go 75 minus 20. Right? We always, the union is just whatever is in the two sets in this case. So we want to go 75 minus the outliers, goes there. NA is 20. NB is 40. And this is what we're going to figure out. So let's clean this up. This would be 55. 20 and 40 is 60 minus N, A, and B. We subtract 60 from both sides. Negative N, A, and B is equal to negative 5. And then it stands to reason that the intersection is just 5, right? Because we divide both of them by negative 1. Once you have the 5, this is just a refresher, okay? Because it's helpful. So once you have the 5 figured out, we go 20 minus 5 is 15, 40 minus 5 is 35, and just make sure this is 20, 20 and 35 is 55, and 20 is 75. So if we add up all these numbers, we get our 75, so we're doing good. What's the universal? Not even a question, right? We know that that's 75. But now we switch it up. Now it says probability. I want you to highlight this. I don't ask for n of these numbers. I ask for p of those numbers. Probability. Note, asking for probability. So it'll be NA over NU. Okay, like you're gonna start thinking of, I need to stack things. Okay. What is NU for all of these? It's 75. That's not a question at all. We're gonna go ahead and write 75 under all the probabilities there. What would be probability of this? Do you remember this notation? What does this notation mean? Any brave volunteer on a Monday morning? What does that mean? Yes? A not B. That's right. A not B. So we want only A not B. So it's the 15. So you grab the 15. There you go. This is probability of B not A. So we'll take the 35. I should be reducing, I know that, okay? What about this one? Probability of A or B, union. Union means I want everything in here. In a sense, you add up all these three numbers, or what's the other way to get the union? You go universal minus outliers, right? Regardless, that is 55. So I'm going to go 15 plus 5 plus 35. That's 55 over 75. I must do this here, okay? Or you just go that the probability is out of 75, and we just go universal minus outliers. That is still 55 over 75. So regardless of how you do it, whatever information you have available, you do that. What about this? What does this mean again? Forget about the P for now. What does that mean, A or B not? These are outliers. What's the probability of someone not liking either one of the pizzas or toppings, or not liking either one of the sports, or not being registered for any of those courses? That's what we want here. For us, that's 20, right? But remember that when you have a not, you go universal minus it. So you could have gone 75 minus 55 to also give you that. Okay? What about this? Odds of B. Odds of B, of some element being in B. It's basically saying B compared to not in B. How many B's do we have? How many elements are in B? Are in B? 40. And therefore, how many are not? Let me just bring this up again. There are 75 minus 40, so it's 40 to 35. There we go. Odds against A. If it's against, then you want not A first and A second, like that. I focus on the A's, like the not I will do later. How many are in A? 20. And therefore, this would be 75 minus 20. So this would be 55 to 20. How do I know that I'm most likely doing this correctly? How do I know when I do odds? Add them up and see if you get your universal. 55 and 20 is 75. 40 and 35 is 75. So you're on the right track. I'm not guaranteeing you that you're going to get this right, but there we go nonetheless. So this is how we deal with probability. So probability and set theory kind of mix. They mix up here in this case. So don't forget about pi. It helped us figure out what we needed. And then when it switches to probability, it's always universal, universal, universal at the bottom. Okay? So just apply what you know about probability and odds and use your Venn diagram to help you out. Exciting stuff, eh? All right. Here we go. This is just a regular word problem. When you see these, you will notice that, oh, this is Venn diagram here. This is Venn diagram. I should probably do a Venn diagram. It's gonna become apparent after a while. A car company reports that for a particular model, 43% have heated seats, 36% have sunroofs, and 49% have neither. If it said both or neither, anything like that, you should realize, wait a minute, there's my set A, my set B, and the outliers, wouldn't you say? I hope that when you read it, that's what you're thinking. If it has neither, are these events mutually exclusive? Show your work. Check if the sum is what? We're dealing with probabilities. So what's the sum supposed to be if it's probabilities? We're looking for 1 or 100%. Okay? Check to see. So 43% plus 36%, that's set A, set B, plus the 49%, the outliers, That gives us 128%. Since it is not 100%, we know that events are non-mutually exclusive. They are joint. That's basically what this fancy thing is saying. They are joint in a sense. So B, find the probability of a car having both. Let's rewrite that with notation. The probability of the car having heated seats, let's call that H, and sunroof. That's basically what that is asking for. The probability of heated seats and sunroof. So let's do a Venn diagram. What's my universal? It's probabilities. It's 100%. If it's percentage that they mention, it's 100%. That's my universal. They don't have to tell me that. Heated seats, we were told it includes 43% of cars. Sunroof, it includes 36% of cars. And in this case, they say that 49% have neither. So that's your outlier that goes on the outside. Let's figure out the probability in between. Use pi. I'm going to call this x, okay? The middle. You need the middle. You need the intersection to solve this. And I'm going to use pi. 100 minus 49. That's the union, okay? That'd be 43% plus 36% minus x. That gives me 51. And if I go 43 plus 36, that's 79 minus x. I subtract 79 from both sides. End up with negative x is equal to negative 28. Perfect. I divide both sides by negative 1. And I find out that x is 28%. Now, for your final answer, bring in units at that point. And I'm going to now write inside the Venn diagram. I know that the overlap is 28%. We go 43 minus 28 to get 15 is just heated seats, only heated seats. 36 minus 28, that's only sunroof. And there you have your filled in Venn diagram. But this is, I circled my final answer here. 28% have both. Okay, that is the one that I actually needed here. 28% have both. Okay. C, determine the probability of a car only having sunroof. Probability of sunroof, not heated seats. I need to pause here for a little bit. I need to make sure you're awake for this one. Remember on the previous question, I'm just going to go take you back here. You don't have to flip, you just have to look. Were we told that these numbers were percentages? We were not told that. There's no percent symbol anywhere. So my universal was 75. I had to write everything over 75, correct, to get my percentage that way, to get my probability. Here, it's already a percentage. So if you just say 8%, right, sunroof, not heated seats, that's fine. You don't need to go 8 over 100. You could if you wanted to. It's the same answer, 8 over 100, but don't go 8% over 100%. That would be incorrect. So just go 8 over 100 if you want, or 8%, and you got it, okay? Okay, I'm gonna ask you to try page 30, and I know you're not gonna like me, but I need to do one more example. Before we go. And I already I took the liberty to figure out, at the top of 31, let's go to 31, examples involving dice, okay? You need to know your dice. I would say make an outcome table if there's 2 dice. It's the best way to solve it if you're not sure. Some students can just envision it and they kind of just picture it. I can't. Even myself, I'd be like, just make your outcome table. Okay. What is the probability that the sum is greater than 8? So here it is. The probability. So we know you're going to have to stack things. Sum is greater than 8, or something else, or a multiple of 5. State the odds in favor as well. We're not going to worry about the odds at first, okay? So basically, for A, probability of G8, okay, or M5. I'm just going to try that. That's what this is saying. So technically, guys, whether you know if there's an overlap or not, this is the safest thing to do. We're going to figure out our G8s. We're going to figure out how many give us a sum greater than 8. We're going to go and figure out how many give us a probability of multiples of 5. And then we're going to go minus probability. I'm just going to say both. We're going to do that no matter what. Let's go find, I'm going to use this color for G8. I'm going to use this color right here to go find my greater than 8 sum. And you see, right, there's a sum of 2, 3, 4, 5, 6, 7. Do I select 8 as well? Greater than 8. So I need to go one up. So for me right now, greater than 8 is this right here. That's G8. Okay, this is G8. These are the outcomes that give me a sum that's greater than 8. So let's go ahead and fill that in. How many are those? This is like same as the AC, right? It was just worded differently. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them. So let's go ahead and figure that out. 10 out of 36 are G8s. Next, multiples of 5. What is multiple of 5? 5, 10, 15, and so forth, right? You start with a number, then you go up by the number. So where's my multiple of 5? It's right here. Those are all multiples of 5s. And the next one would be 10, correct? So how many are there? 1, 2, 3, 4, 5, 6, 7. Yeah, I know. 6, 7. It doesn't get old, eh? It used to be 21. I don't know if you were that's still funny? Yeah. So if I did this, if I went 10 plus 7 and said, Mr. Rickson is 17, you'd be wrong, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You don't want to double count this. You're counting it twice. So one way to just go about it is to say, I'm going to take away these 3 because I already counted it over here. Okay? And that's what you do. So 10 plus 7 is 17, minus 3 is 14. So this is the correct answer. I'm going to give the overlap a different color. I'm going to give that a different color. And I'm going to say I took away those 3 outcomes because I already counted them when I added up my G8s. Okay? So, Mr. Dirksen, why couldn't I just count everything and just come up with 14 out of 36? Absolutely, you do that. I'm just showing you, if you didn't have an outcome table, you should have thought of it, oh, there's probably 10 out of 36, and 7 out of 36 is the multiples of 5s, but there are three that I'm double counting, so I'm going to subtract them, okay? So that's that. For B, the probability that the sum is greater than 8 and a multiple of 5. And, can you grab a color that you haven't used yet? We used OR here. We're using AND here. Probability of G8 and M5. You're basically wanting R in both. These are shared. These are, I'm just going to say it this way. We want those ones there. This is G8 and this is M5. How many are in both? How many are in both? We just figured it out earlier. 3 are in both camps. Okay, so I'm going to give this a green here. So in this case, all you need to do is figure out your G8s, figure out your M5, and then realize, oh, it's 3. There's only 3 outcomes that meet the criteria. So I'm going to go 3 out of 36, okay, is the answer. And I'm going to give this a green circle. So when it says AND, it needs to meet both criteria. If it says OR, you want to add up your union. You're making a union between the sets, but you don't want to double count. You're basically using pi, and for the AND, you just want to find where they're overlapping, okay, this part. Fun stuff, eh? I know. I'm not worrying about odds right now. I'm not even going to do it because that's, you probably know how to do odds at this point. So I'm going to stop here. The bell is almost about to go. Okay, this is what I want you to try. Pages 31 to 32. There is a deck of cards question there, so you kind of need to make sure you look at your study sheet. You're listening? Look at your study sheet. Do I have enough on there to help me with the deck of cards? Can I answer it? There might be overlaps. There might not be. Okay? Thank you, guys.